All right, hello everybody. Um, Welcome to what is this, week 3 now of this online learning. Thank you for all your hard work so far and everything you've done, turned in. I want to go ahead and thank you for your continued hard work moving forward. It is difficult to teach yourself this content basically because you're having to do a lot of work, a lot of work on your shoulders. And that's hard, but we'll get through it. And thank you again for coming to these meetings and doing the best you can, watching the videos and doing the best you can. So today, I'm going to go ahead and get started rather quickly with the sheet that is labeled as Intro to Probability and Statistics, Monday and Tuesday. So this is for today and tomorrow. If you're watching this on Monday, it is 6 pages, and that seems like a lot, but a lot of it's filled up with like pictures and graphs. Okay, so there's 4 main points we're going to get to in the lesson, and then you have some practice. And luckily, a lot of the practice is just like filling in a chart of some sort, or drawing some sort of chart. So it's not a lot of computation. We'll get to that later. Wednesday and Thursday and Friday will be more computation, but today and tomorrow is a lot of just getting familiar with different kinds of graphs. So don't be too stressed out about the number of pages. When you have big pictures, page number goes up. Okay, so probability, and I also kind of want to start a little bit later, probably come Wednesday, to give people a little more time to wake up. It's early in the morning. We'll see. I will send out a message and see if more people would and get a response on that. But for now, data plots and shape. Okay, so there's a couple different ways to represent data. And so for an example on this sheet, so if you don't have it, go ahead and open it. Open it in another tab. You can listen to this as we're kind of going through it. I'm not writing anything on the board yet. I'm just talking. So go ahead and open up days 11 through 12 or the Monday and Tuesday link, so you can start looking at the same sheet that I'm looking at. Okay, so Bob believes the basketball star. Below you'll find the total number of points that Bob scored in his last 40 basketball games. Okay, so it's like on the first basketball game, he scored 8 points. In the second one, it was 15, 10, 10, 10, 15, and so on. So this is the number of points he scored per game, each game. Okay, and they're kind of all put together in a list. All right. One way of representing this data is through what's called a dot plot. Okay, now a dot plot, you see that number line down there. A dot plot is just a number line with some added steps. So this is a dot plot. Okay, and so this one has 20 here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 20, so 1, 2. Okay. A dot plot, it's the same one that's on the sheet, so I'm not making anything up here. You can see a little cleaner on the sheet in front of you. Okay, so what this says is a method of visually displaying this distribution of data. So what it means there is like one way of representing how many 5s we have or how many 6s we have, and kind of checking like all at the same time without like a list of and a tally mark of how many we have of each number. One way you can do it is draw a number line, and then for a dot plot, you either make a dot or an X or a mark of some sort above the number that's in the list. Okay, so for example, on the first one, the number is 8. Okay, so the first game he scored 8 points. And so what you would do is make a little dot above 8. Bigger so you can see. Quality is a little bad today. I'm recording from a different laptop. I'm in the middle of a move, and so my camera got packed away. Sorry about that. It might be a little unclear. So the next number in the line or in the list would be 15. So above 15, I would put a dot. And I would repeat the pattern for the rest of the numbers in that list. Okay. So let's go ahead and do that. You could, if you're following along, go ahead and start it. I'm going to fill them all in. So again, the next one's going to be 10. Now, I see 10 again. I don't make the dot bigger. I just make another one above that one. And that shows me that I have, so far, when I've analyzed 5 games, he scored 8 points. He scored 10 3 times. He scored 15 points. That's kind of what that's showing. Okay, so let's keep going. Let's see. Again, if you have it open, go ahead and start doing it just as we would in class. Fourteen. All right. I think the distribution should look something like that. Yeah, so good point, Ms. Tillman there, that when you're dealing with these and you are working with this big long list of numbers, it's actually really handy if you take your pen or on the computer, cross out the numbers as you use them. It was, I got in the middle of there and it was kind of hard to remember how many I've done or which one I was on. So an easy way to keep track of that, if you use 8, you just cross out that 8, use the 15, cross out the 15 as you go along. That kind of helps eliminate a little bit of the confusion. And it allows you to keep track of when you're on a little bit. Okay, and so let's go to dot plot. You got dots, and you've plotted the dots. It's pretty straightforward. It doesn't show us a lot of stuff, but it's a really easy way to represent simply the data that you have, and kind of it's an easy way to see, okay, this basketball phenom is scoring really within the 8 to 11 points per game range pretty frequently, more frequently than he is scoring 5 and 7, but also more frequently than he's scoring 12 through 15. So not necessarily a basketball star, but pretty consistently in the 9 to 11, or sorry, 8 to 11 point range. And it's kind of hard to see that when we're just looking at the list of numbers. So a dot plot allows us to kind of compare that data easily. Okay, so the next one is a histogram. Okay. So let's just talk about what this is. This thing called subdivide. Let me just get to the explanation, and then I'll break it down for you like normal. Subdivides the data into class intervals. All right, it's a lot of math, but I'll get there. and uses a rectangle to show the frequency of observations in those intervals. Okay. So we're still using the same data. Okay, it's the same list of numbers, but the 40 basketball games, all of this data, we're going to represent it a little bit differently. And this time we're going to be using what's called a histogram. So I'm going to kind of section this off. This is called a histogram. Hopefully you can read that. I mean, if you can't. Okay. So what this means is you can kind of see that chart there. It kind of looks like you are in like Excel or something, and you just took a section of the cells and then printed it on the chart or something like that. There's little boxes, and they're sectioned off. It looks like a graph, but the boxes are a little squished. It's not even. Okay, because it's not a graph. It's important to know that this is not like the first quadrant on the coordinate plane. It's not XY graph, and this is just the positives. Okay, this is something completely different. This is a histogram. So the first thing you need to do in a histogram, and I'll get to the graph in a second, but we have to count the intervals and the frequency. Okay, if something's happening frequently, or somebody asks you how frequent is something happening, they're talking about how many times does that thing happen in context. Okay, so if we have intervals, I'm going to do the frequency table first. Okay, we have intervals and we have frequency. Okay, so the intervals that we are using, 6 through 8, 9 through 11, 12, you can still see that. Cool. 12. Once that move. See all that? Okay. Once I move. Okay, and again, this is the same thing that's on your sheet. So if you have the sheet in front of you, it's just going to be a lot easier. Okay, so on the interval from 0 to 2, on the interval is what I'm going to be using, that word, on the interval, that sentence. And what that means is from 0 to 2. So is he ever scoring 0 points, 1, or 2 points? I don't think so. We don't have any dots there. Those numbers were not in our list, okay? So frequency would be 0. Catching on? Let's try again. Let's see if we can catch on. From 3 to 5, we look at our dot plot, or we go back and we check the list of numbers. Now, if we already have a dot plot, this is significantly easier because it's just easier to check the frequency tables here. But if you don't, again, you're going straight to a histogram. It's not the end of the world. I would just, like Ms. Tillman said, go back in the list as you're going, cross them off. Make sure you're crossing off the ones you've already used. So let's check 3 to 5. On 3, didn't score any. 4, we don't have any dots. 5, we have 1 dot. So that'll be 1 right there. All right, now let's check 6 to 8. Same process. So 6 didn't score any. 7 scored 1, 2, 3. And 8 scored 1, 2, 3, 4, 5, 6. So from in this range right here, 6 to 8, we have 9 total. Okay. Now, let's see if we can continue that pattern and see what's happening. So 9 to 11, 12 to 14. Now, the frequencies, these are going by 3s. They don't have to go by 3s. They could go by 100, depending on the context of the situation. Okay? So it's not a hard and fast rule that the frequencies are going by 3s. I think for the sake of this, you're given all the intervals that you need for all the Pikes problems, so don't worry about that part. And just to keep things simple, we've made all of them for you at the moment. So from 9 to 11, you gotta count all the dots in the 9 to 11 range. Okay, so 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. All right, and then you do from the 12 to 14 range. 4, 8, 11, and then 2, and 0. Now, we had 40 basketball games that we were collecting data from, okay? So we should have 40 dots. I don't want to count all the dots, but what we can do is count up all of the numbers we found in the frequency column, okay? And we can make sure that adds up to be our total number of data points or total number of numbers in that list, so we can make sure we counted all of them. So it's 10, 27, 38, 40. Okay, so one way to double check yourself and make sure you didn't skip any numbers or double count numbers is to make sure that you either have 40 points, you have the same number of points as numbers in the list in the dot plot, or the total number of frequency. You add up all these frequencies to make sure it's the same number as the total number of values or data points in the list, okay? Again, that's to double check yourself. All right, now we have this weird graph looking thing, and what I'm actually gonna do is do it over here to the side. It's gonna be a little rough, so bear with me. We should have 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14, 15 through 17, and 18 to 20. I think that's it. So, so 0 to 2, I'm gonna kind of 0 to 2, 3 to 5, 6 to 8, 9 to 11, and I'll move this out of the way. I'll explain everything I'm writing if you can't quite make out everything. Okay, so what I'm doing here on the bottom, and you kind of do it here as well on yours, is I need to label along the bottom my intervals. Every category of interval that I have needs to be one of the sections, one of the columns in the histogram graph. Okay, so the first one lines up with my first interval section. Okay, so the first column needs to line up with my first grouping of intervals, the second one with the second, and so on. It's not like we're counting on that. This is why this is not an XY graph, not on the coordinate plane, because it's not counting 1, 2, 3, 4, 5, and we're not just simply graphing it. We're graphing something totally different here. And to do that, you have to label along the bottom axis, not the x-axis, along the bottom down here. You have to label 0 to 2, 3 to 5, 6 to 8, depending on which intervals you have. That's where I got all that information. Now along the side, what this actually has here is these are going to be our frequencies, okay? And so it's the most, 17 is the most frequent. Now on your graph, you will shade each cell per frequency, okay? So what that would, I'm not going to draw 17 lines because it's going to get insanely messy, but I'll walk you through it as we go. All right, so now what we'll do, I think this is when it starts to make a little more sense. You check 0 to 2 and you look at the frequency and you see, okay, there was none, so I don't shade anything in. Then you check 3 to 5 and there was 1. So in our frequency column, and so I would go over here in my 3 to 5 column and I would shade 1 of the boxes in. Okay, and that's how you fill in the histogram. You keep going there. So 6 to 8, you have 9 in our frequency. So what you're going to do is shade in 9 of the boxes. 1, 2, 3, 4, 5, 6, 7, 8, something like that. 9 of them, however high 9 goes. Okay. And then you're going to take, and again, I'm not counting by ones on my graph, but your graph has all the lines detailed out. So you can actually shade 1 cell, 2 cells, 3 cells, as many as you need. Mine's just a little rough guess here. Okay, so 9 to 11 is going to shade 17 of them. Okay. So, that's probably going to go almost all the way to the top there. Something like that. Okay. And you check 12 to 14, and the 12 to 14 column, you want to get to 11, which is going to be somewhere in there. Okay, then you want to do the 15 to 17, which is 2. That's a little bit bigger than 1. And then you take the 18, 20, and that's 0. Okay. So it looks similar to our dot plot, but it's a little more uniform. It's just detailing it a little bit differently. I would say it's not as accurate to the 9, the 10, the 11, because there's no way we can tell just how many shots he made that were 9s, 10s, and 11s specifically. But it does give us the data in a little more, I guess, more consumable way, because it tells us we can analyze it a little differently, I guess we can say. It's not the exact same, but it breaks it down. As the definition says, subdivides the data into these intervals for a little bit different purpose, so you can see frequency a little better. Because counting all the dots is going to be hard every time, so this is kind of a little bit easier to see frequency. Okay. And one thing you can do, sometimes it is already labeled for you. You can go ahead and label along this side. On this side, if you want to label every box, you can go 1, 2, 3, 4, and kind of like as if it was the y-axis, but it's not. You can label, 1, 2, 3, 4, 5, and label all the boxes if that helps you before you begin to shade for division. Okay, so dot plot, histogram. 2 things where you have a list of numbers, you have a bunch of numbers, and you want to represent them graphically, so you can kind of analyze them. 2 ways to do it. Third way to do it is called a box plot. Okay. So again, good thing this is on YouTube. You can pause it and go back. I'm going to keep moving forward. If you have any questions, you can put them in the chat box. So I'll leave that up there for a second, but I will end up erasing that here in a minute. So box plot. This lesson should go about 45 minutes, I think. We'll have about 10, 15, and then we'll probably be done with this. Okay. So this is the same list of numbers, okay? It just has them again, so you have to keep scrolling. This is a little more detailed, a little more involved than both of the ones we just did. But it's not crazy, okay? It gives you a little more detail into the analysis of the numbers, and we'll talk more about what each of those things mean when we get there. And also on Wednesday, I'll go into a little bit more detail about why we need all this stuff and how it's used Wednesday. And again, not all of this isn't all computation at the moment. This is we're not like using formulas and stuff. Okay, so we're kind of just looking at data and analyzing data in a unique way that you've probably never done before, or you might have done it in middle school a little bit. So this is new, okay? So should be, or at least for our class this year. So we have this box plot, and I'll get to why it's called that in a minute. Skip that big definition, and let's go ahead and go to the order, that section where it says order the data values here. Okay, so what that means is we need to list out the numbers in order, not the order it's given to us, increasing order. So we're gonna find the lowest one, and then we're gonna go up and up and up and up. Now, if I had this here still, that'd be super handy, but I erased it. So what you'll end up doing is you'll look at all of them, and you kind of go through and see how many you need. So 5. And again, what you'll do is we're going to make a long list of all the numbers in order, starting with the lowest being 5. Okay. Okay. You can double check yourself with this frequency table here. So it looks like 7, 8, 8. Is there? Yeah. So 1, 2, 3, 4, 5, 6. Yep, nice, got it. 3 7s and 6 8s. 7, 7, 1, 2, 3, 4, 5, 6. Okay. So 9 to 11. So what I do is I like to go through and count all the 9s, go through and count all the 10s, and kind of do it that way. Instead of seeing, okay, 1 9, write it. 1 9, write it. It kind of makes things a little more easy for you to keep track of. As you saw, I skipped a couple 7s just a second ago. So let's check the 9s first. 1, 2, 3, 4, 5. Yep. So 9, 9. Okay. 5. Let's check the 10s. So what I would do is go through and count them. It's like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then for 11s, looks like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, then we're on to 12s. Looks like we have 1, 2, 3, 4. 1, 2, 3, 4. 13s, there's like 1, 2, 3, 4. Again. And 14s, we have 1, 2, 3. Good. 14, 14, 14. And I think the only thing we have left is a couple 15s, 1, 2 15s. Okay. And I was kind of using my frequency chart to double check that. Now, if I still have that dot plot, that would be much easier because I would know how many of each number I would have. All right, so I need some room here. So let me go ahead and erase this. All right, so there's a couple reasons why we have this. There are 5 things we're looking for. It's called the 5-number summary. And it's called that for a reason. And again, you see another number line, and we'll get there in a second. But this 5-number summary has the minimum also known as the min. That's what we call that. So let's actually not draw that line. We have what's called the lower quartile, or Q1. We have the median, which is the middle number, okay? The upper quartile, or Q3, and the maximum, the max. Okay, so middle number, the lowest possible number. That's why we have all this in order, okay? Because we can't find these without having it all in order. So look at the lowest possible, the middle possible number. That's going to be 5. Now let's check the max possible number. The last number on our list is 15. For this, this presents it in order, okay? But you can kind of jump around. It's going to be easiest to find the maximum number and the minimum number, and you can jump around from there. But you're going to want to find, after the minimum, the maximum, you're going to want to find the median, okay? Because to find these two, and I'll talk about what they are in a second, I find the median first. So there's 2 ways you can do this. The way I would do it, which is the simplest to me, is let's figure out how many numbers we have. We know that already, it's 40. And then count to the middle. What's half of 40? 20. So find the 20th number, stop. And I always double check myself by counting backwards from the last one as well. And let's see what that looks like. So let's count up. 13, 14, 15, 16, 17, 18, 19, 20. So I'm going to underline that one. Let's count backwards to double check. That's okay. It's okay that I landed on 2 different numbers because there's not a number that's going to be in the direct middle of an even number. Okay, so if there's 40 of them, the middle is going to be the 20th. You're going to have to average the 20th and the 21st number. So what we do here is we check the middle, the direct middle actually is right here. Right in between those 2 tens. But so when you find what's in between those, you add them up, divide it by 2. What's really good, if it's the same number both times, if it's 10 and 10, or if it's in between 9 and 9, it's just that number. Okay, so I'm actually just using that. Now, if it was 10 and 11, it would be 10 and a half. It'd be right in the middle of those 2 numbers. But it's just 10 and 10. So the average of that would be just a regular 10. Okay. So that process is going to repeat a couple times with this lower quartile and upper quartile. All right. Let me kind of give some context of what this means. We are basically grouping the data in a couple different ways. And for probability and analysis sake, for understanding the data and interpreting it, you need what's called the lower quartile, which means the bottom, about 25% of the numbers, and the upper quartiles are the upper 25% of the numbers. And the middle 50% is everything in between. That's the part between the lower quartile and the upper quartile is that the majority of the data, where it's kind of, where we had our histogram earlier, kind of like went up like that towards the middle. All of this analysis is kind of like looking for ways to get that representation a bunch of different ways. Let me show you how to find it. It's as simple as counting. So what you have to do is you kind of have to break this list of numbers into two sections. The first grouping and then the second grouping, which is everything else, okay? So for the lower quartile is the first bit of numbers, the first half of numbers. So what you'll do is you'll take the first one, count the halfway, go backwards and do it again. So we should have 20 numbers in each section. And so you count the halfway, so 1, 2, 3, 4, 5, 6, 7, 10. Underline it. Go backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh. It's an 8 and it's a 9. Don't fret. What we have to do is we got to find the number that's in the middle of that. If I always go back to money, that kind of confuses people sometimes. So if this makes sense, listen to it. If it doesn't, forget I even said it. If I have $8 and you have $9, we put our money together and then we split it evenly. We took the average. We would be left with $8.50 each. Another way you can do that and show that is you take the two numbers, is 8 plus 9, you divide it by 2. It's going to work every time. You take the number on the lower part, you add the other number, and then you divide it by 2. So that's 17 divided by 2, which is 8.5. So that's actually the number in between 8 and 9. It's 0.5. It's halfway in between 8 and 9. Okay. So that's actually the number right here. This is our lower quartile. 8.5. If this isn't clicking, making absolutely no sense. There's other videos. I encourage you to, Khan Academy is always good. You can find other videos, other explanations of all this. I'm also open for any questions if you have any. So, same process for the other side. So we found the minimum, we found the maximum, we did it for the median. Counted both ways and took the average. For the lower quartile, we did the same thing, starting with the lower part and the median. So for the upper quartile, you're going to start at the median and go to the maximum. We use the other half of the numbers. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we're going to get lucky here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so again, we got to find the number right there in between. We got to find that number in between the 12s. Just like the 10s, though, if it's two of the same number, it's just going to be that number. All right. So the upper quartile is 12. All right, it's a lot. The key there, though, is to find or to put the numbers in order. You got to list them out in order in order to start any of that. And there is one example on doing that. It's on number 5 on page 5. Okay, but there's 2 more things I want to get to before we get out of here. So what I'm going to do actually is I got to leave these numbers, so I got to erase all of this. Again, luckily on YouTube. You can go back, send me a timestamp and say, hey, I was confused at 5 minutes and 2 seconds. Can you tell me about that? All right, so I have the same number line here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again, it's a little cleaner on your end, but it's okay. So this 5-number summary is going to be used on this number line now. This is why it's called, this is going to be why it's called a box plot. You're plotting a box, and the ends of the box are actually the lower and the upper quartile. I want to get to that in a second. So you're going to first plot 5 dots. The minimum, lower, medium, upper, maximum. Minimum is 5, so plot a point there, plot a dot there. Plot the lower quartile at 8.5. But there's no 8.5 tick mark. It's all right. Go in between. Plot the median, which is 12. Plot the upper, sorry, median, which is 10. Apologies. Plot the median, which is 10. Plot the upper, which is 12. And the maximum, which is 15. All right. So I said we're happy to have a box. Now what's going to happen is to actually signify the lower quartile, draw a line. That line's a little too big. Draw a line in between these 3, and then we're going to make a box. And then we're going to connect the ends here. I'll do it again. All right. So I'm going to walk you through one more time. Let's plot everything. 5, 8.5, 10, 12, 15. I just heard all of your brains go, what? So our box is in the middle here, okay? Our box is going to contain the first quartile, the median, and the upper. I need to draw a box. Because the ends of that, so when I have this box plot, the ends of my box there, the lower end signifies that line. Where that lines up means that's my lower quartile. Where the middle line lines up means that's the median. And the upper one means that's the upper quartile. The higher box, the max, the right side of the box means that's my upper quartile. And I have to connect these endpoints over here, the minimum and the maximum, to my box. And what's cool about this is if I was given this, just that, I could write out my 5-number summary for that without needing the list of numbers. I could just put that there. I could have this and I can read it as this first point is the minimum. This line, this left side of the box lines up with the lower quartile. The middle line lines up with the median. The upper, or the right side of the box lines up with the upper quartile, and then the right point over there, the far point, lines up with the maximum. So all of the histogram, the box plot, and the dot plot, they are, if we're given the graphs without the numbers, we can still do some analysis of the data that we're going to get to on Wednesday. And or we can kind of draw them to do that a little easier. All right. Now there's one more thing I want to talk about that is the most backwards, makes absolutely no sense, like face values. This is one of those things that mathematicians somewhere decided to use a word that's going to confuse you. So we're going to have to get used to using the right way. Okay, so if you scroll down to page 3, it says determining shape. Again, this will be up there if you have questions. Let me know. We're almost done. Last thing. So there's a couple different ways. If we had a list of numbers, there's a couple different ways things could be shaped. Now, I'm actually going to do this with the histogram. Well, if you look there, it has a bunch of different ways. It has the histogram, the dot plot, and the box plot. All of those things can be shaped this way. That line right there is the median. Okay, so all of them can be shaped this way. It can have that, you can, as you can see, connect the dots, connect the maximums, the tips there, and you will have a couple different ways it's drawn. Now, here's the confusing part. There's 3 ways we can describe this. The first one makes absolute sense to me. Symmetric. It's even. Our median is right down the middle, or thereabout. Okay, it's right about down the middle. It's not off the left side or off the right side. It's right in the middle. We talked about the axis of symmetry earlier in the year. This graph is pretty close to being symmetric. And a lot of times with this probability and stuff, pretty close to being is pretty good. So pretty close to being symmetric, pretty close to being right down the line is going to be symmetric. Is how that line right above there, that little fill in the blank spot in your sheet, right, symmetric right there. Okay, there's another one. If you read up in the little sentence above, it says there's skewed left and skewed right. Okay. This is where it gets confusing to me, is it's flipped. Okay, so skewed, again, it's flipped. So it's hard to, when you see skewed right, you think the top part of the graph, like the hump of the graph, should be on the right side, but flip that, okay? Not true. This is why it's confusing, because this graph is actually skewed right. You're actually looking at the lower part of the graph, like the slope, the downward slope of the graph, or so the upward slope. Whatever part is smaller, that's actually the side you're looking at, not the line. Now, another way you can memorize that is look at the line and say, okay, it's on the left side, so it's skewed right. Another way you can think about it is imagine that this is like the way I picture it a little bit is this is like a water balloon or something. And what I did was on the right side of it, I squished the water balloon. And so all of the area went over here. So if that also helps. That's one way you can think about it. So it's symmetric if I'm just leaving the water balloon alone, but if I squeeze the right side, all of the water is going to go over to the left, over here. Okay, so that's skewed right. And if I squeeze the left side, it's going to go over there. And so that means this is going to be, I'm skewing it on the left side. So this is skewed left. And again, that's a way to talk about the graphs themselves and the data. But you can't do that. You can't determine which this is without having either a histogram, a dot plot, or a box plot. And you can talk about histograms, dot plots, and box plots, the 3 things we just talked about in this video. You can describe them by being symmetric, skewed right, or skewed left. Again, imagine you're squeezing the water balloon on the right side, moving all of the water over to the left, skewed right. If you're squeezing it on the left side, you're moving all the water that way. So imagine again, this is a water balloon, that's what would happen to all of the water. Move over there. Skewed left, squeezing it on the left side. So for the rest of the day and tomorrow, there's only 3 pages of practice problems. But again, don't get too scared because I deleted some of them, so the numbers don't really line up there. The first one, just create a dot plot. Remember, you don't have to order them. For the second one, frequency table, and then do the histogram. So you want to count the number of times the numbers 68 through 71 appear in that list of numbers. Write how many times it is. Is it 10? Is it 2? Write that. And then go shade them in the boxes over there. Box plot's a little more intense. Give me your best bet there. Remember, you got to list them in order, and then Once they're in order, find the minimum, the maximum, and then the middle, and then kind of go from there, and then draw the box as best you can. And for 7 through 12, all you need to do is say skewed right, skewed left, or symmetric. And you can kind of see, if it helps, you can kind of trace, similar to what it looks like above, you can kind of trace this little thing here, this little graph, if you want, or you can kind of just look at it. Okay. Again, please let me know you have today, tomorrow to work on this. This is one of the ones, let me repeat, this is one of the things, this will be open until Friday, but we're going to be moving on Wednesday onto another sheet. We're going to build off this, but we're going to be moving on to another sheet. Okay, it's been a little long, about 50 minutes, but 2 days worth of lesson. So again, please do let me and Ms. Tillman know. I think we're still planning on having a tour session. So please come to that. I'm going to probably move it back to 10 o'clock. I saw people start joining a little bit later, so I can move back a little bit to help you out these last couple of weeks here. Again, we're trying to do as much as we can and really finish out the year strong online. So give me the best you can. And let me know if you have any questions. It helps if you find the timestamp in the YouTube video. I'm going to post it as soon as I can, and I will see you guys on Wednesday.